Hello everyone, I am Pallavi Sethmanik and I am the student from MIT ADT University, and today I am going to present this PPT on the topic of advancement in food packaging. So what is packaging? The packaging encloses the food product to protect them from contamination and spoilage. We will see what are the advancement is done in the food packaging. Coming to the next slide, which is the content, in which we will see the introduction to packaging, what are the functions of packaging, what are the history of packaging, and the waste utilization, the emerging trends in packaging regulations, and the market trends. Now, let's start with a quick introduction to what packaging is. The packaging is the enclosing of food products to protect them from contamination and spoilage. Packaging is a means of achieving safe delivery of the food products. For example, from the moment food leaves the farm until it reaches to your kitchen table, the packaging plays a very crucial role in maintaining its quality, protecting it from the contamination, and making it easier for us to store and transport. So, together we will uncover how something as simple as a package is making a big impact on our planet, our health, and the way we live. Now, coming to the functions of packaging, first we will see what is the promoting and selling the product, in which the packaging plays a very important role in marketing by attracting consumer attention. Second, the defining the product identity. It established the brand identity through design and labeling. Third, which is the providing information, the important information like ingredients, nutritional facts, and the expiry dates can be easily conveyed through the packaging. Then the fourth, the protecting the product. It safeguards food from environment, chemical, and the biological threats. Fifth, expressing customer needs. The packaging also responds to the consumer needs for the convenience, safety, and sustainability. Now, coming to the history of packaging, it refers to the evolution of materials and methods used to protect and transport the food products. In the ancient times, around 3500 BCE, the clay pots, leaves, and the pottery was used to store the grains, oils, and the liquids. So the early humans used this kind of material for the transportation of the goods and the food products from one place to another place. So the second is the Middle Ages. In the Middle Ages, the the wooden barrels and the crates were used for transporting the bulk goods like wine, beer, and the grains. And the third, which is the industrial revolution. In the 19th century, the tin cans are introduced, and there were the widespread of the cardboard boxes led to the very famous, and also the paper-based packaging is also introduced in the industrial revolutions. So from this industrial revolution, the many more new ideas have been increased in the packaging industry. And around the 20th of century, the plastic packaging, in which the first the canning and the vacuum sealing were used to enhance the food preservation and the transportation. So, in the plastic packaging, in the 1900, the invention of plastic is done, which became quickly one of the most used packaging material due to its versatility, durability, and cost effectiveness. And the smart packaging, in which the incorporation of the technologies like RFID or QR codes have been successfully introduced, and which are sustainable for our environment also. So, in the recent decades, the concern about the plastic pollution had led to a shift towards biodegradable, compostable, and eco-friendly packaging materials. So, therefore, we are using the bioplastics, which are made from the plant materials, and the paper-based product to reduce the environment footprints. So the smart packaging, which is developed in the 21st of century. So coming to the next slide, the types of packaging, in which we will see what is smart food packaging, active food packaging, and intelligent food packaging. So the smart food packaging uses the sensors and new technologies to monitor the product that connects to the digital world. So smart packaging can monitor the condition of the food. For example, the anthocyanin, which are natural compounds found in the fruits and vegetables, can use to detect changes in the environment like pH. If the food is going bad, the packaging might changes the color to alert the consumers. So the active now second we will see the active packaging. The active packaging, it is a technology that intentionally releases or absorbs substance to improve the quality and safety. Means active packaging involves the materials that interact with the food to improve its freshness, and that this can include the adding of the antioxidant or antimicrobial agents. For example, the ascorbic acid, which is also known as the vitamin C, is used in the packaging material to prevent the food from the oxidation and the spoilage from like fish, tomatoes, and this helps keep the food fresh for a longer time. Now coming to the next, which is the intelligent packaging. This monitors the condition of packaged foods. Example includes the self-heating and self-cooling cans, and the time and the temperature indicators. For example, the methyl red is a pH indicator. It can change color based on the acidity of the food, signaling whether the food is safe to eat or not. And also the for example, the self-fitting and self-cooling cans have been used in the traveling, or that the consumer can easily accessible for this. The active food packaging, in which we will see antimicrobial packaging. The antimicrobial agents are incorporated into the packaging material, and these agents fight against the bacteria and the harmful microbes that spoil the food. So there are the two types of antimicrobial agents. One is natural and second is synthetic. In the natural agents, like essential oil, plant-based extract, and the enzymes, and the synthetic, which includes the silver nanoparticles and the metal oxides. So in this diagram we will see that the active agents are incorporated into the packaging material. For example, the oxygen scavenger is incorporated. So these oxygen scavengers absorbs the oxygen from the package, preventing food from spoiling too fast. And the second, which is the ethylene scavenger, they they slow down the ripening process in fruits and vegetables. And the CO2 emitters, which helps in maintaining the right gas balance in the package. And so this is about the antimicrobial packaging. So the intelligent packaging, in which we will see what are the thermochromic inks, what are the RFID, and what are the self-heating and self-cooling cans. In thermochromic inks, you have probably seen this before, packaging or the product that change color based on its temperature. The mug shown in the image has a thermochromic ink that changes color when hot liquid is poured in. It visually show that change from off to on, indicating the liquid is ready to drink. Second, which is the RFID, radio frequency identification, which uses the tags and readers to wirelessly transmit the information. So RFID tags can store the data about a product origin, storage conditions, or the expiry dates. And the RFID reader, which captures the information and send it to computer for tracking and monitoring. The RFID monitors the freshness and track the food products and prevent food waste. Now coming to the self-heating and self-cooling cans. So for example, imagine a can of coffee that can heat itself up, or a soda can that cools itself down. These cans have built-in systems that allows them to either heat up or cool down by pressing a button. The self-heating cans are especially useful for outdoor adventures or situations where a stove or a fridge isn't available. The fruit and vegetable industry waste and the byproducts. The issue of food waste and the loss is a significant global concern. According to a report from the Food and Agriculture Organization, 1.3 billion tons of food are wasted or lost annually. So, the key contributors to the food waste includes the roots, tubers, and the oilseeds. These are the leading contributors to global food waste, making up about 25% of the total plant-based food waste. These are staple crops in many parts of the world and are susceptible to loss during production, storage, and distribution. And the fruits and vegetables, the close behind roots, tubers, and oilseeds, fruits and vegetables contribute 21% to the global food waste problems due to their perishable nature. Fruits and vegetables often spoil before reaching the consumer or are discarded due to imperfections, even though they are still edible. And the cereals and the pulses. So these are the staple crops contribute to the 14% to the food waste. Similar to fruits and vegetables, cereals and pulses are wasted during different stages of the food supply chain, including harvesting, processing, transportation, and storage. For factors like overproduction, improper storage, and poor infrastructure contribute to these losses. So, it is estimated that the global cost of food waste and loss amount to USD 936 billion each year. This includes the direct cost of production food mm, that is ultimately discarded, as well as indirect costs related to the environment impact of these waste, example greenhouse gas emission from decomposing food in landfills, wasted energy, and the water resources. The next slide, which is the recent trends for new emerging packaging innovations, the case studies we will learn. So in this slide, uh, I'm going to talk about the recent trends, in which we will focus on how the food industry is moving towards more sustainable and eco-friendly packaging solutions. So first of all, the biodegradable packaging from food waste. This is the one of the leading trend, is the development of biodegradable packaging made from food waste. First, which is the fruits and vegetable peels. With the help of these peels, these are being upcycled into the packaging material, reducing waste from food processing and offering a sustainable alternative to plastics. Similarly, the starch-based packaging, which is derived from the plant sources such as corn or potatoes, is gaining popularity. And the another, which is the edible packaging. Another innovation, exciting innovation, is the edible packaging, which can reduce waste even further because the packaging itself can be consumed. For example, the seaweed and algae based packaging. This is an emerging material that is not only biodegradable but also edible. It's perfect for single use packaging like wrapper for sandwiches or salads. Now, second, casein based films. These are derived from the milk proteins and also being used to create edible films for packaging. These films are effective at keeping food fresh by acting as a barrier to oxygen and moisture. Now the next, which is the packaging from the agricultural byproduct, in which the mushroom based packaging, which is the standout example. It's made from the roots of mushrooms, that is mycelium, which are combined with the agricultural waste to form a strong biodegradable material. This type of packaging is ideal for protecting the packaging from the which is eco-friendly. And the next, which is the innovation in food waste, derived packaging materials. So this is the example which is given is the banana leaves packaging. So banana leaves are being explored as a sustainable natural packaging option, particularly in a region where they are readily available. So this kind of packaging has been used traditionally and now sees the renewed interest due to minimal processing and the biodegradable nature. And the second, which is the pulp from citrus waste. This is the another innovation in which the citrus pulp, as a byproduct of a juice production, can be transformed into the packaging material. And the next, which is the circular economy models, upcycling food waste for the packaging. So these all are the food waste which are being effectively utilized to make the packaging materials effectively, which are eco-friendly and can be easily degradable, and which is sustainable for the environment. The application of fruits and vegetable waste and byproduct in food packaging system. In this table, we will see the how the waste is used to um, to pack a food product, and how this waste is used as a packaging material. So the waste which is used is the pomegranate peel, and the packaging pomegranate peel, in which the packaging material has been made with the use of pomegranate peel, the which is also the active packaging. The pomegranate peel is used in the different concentrations, as we see in this table, and added to the Zane films, and this is applied to and these pomegranate peels are used in the films to protect the Kalari cheese. And the packaging properties of this pomegranate peel, which is the inhibition to the all the pathogens, antioxidant properties, antimicrobial properties, and delay of the oxidation, its flexibility, tensile strengths are means this packaging material is very effective in protecting the food product. Next, the mango peel and the seed kernel. So in the mango peel and the seeds are made into the films for packaging peaches, helping extend their freshness. So the packaging material is which is made from the mango peel, which is effective in the antioxidant activity. The permeability is high, which is the hydrophobicity, and the surface property. In the 39% less O2 is consumptions, and the CO2 less CO2 production is seen in this mango peel packaging material. The waste utilization. So using the food waste for packaging has many benefits, that is reducing the production cost, and also the renewability, means we don't rely onto the plastics anymore, and the biodegradability of the food packaging materials, and the decrease waste and environmental impacts. So there has been the food packaging innovations in the biopolymers, biocomposites, edible films and coatings, and the bioplastics. These are all the food packaging innovations. So first of all, we will see what are the biopolymers. So the food waste which is generated that can be used in making these food packaging innovations, means that waste can be easily utilized for making this kind of bio degradable materials. So first of all, the biopolymers are the materials that come from the plants and other natural sources. They are compostable, and also made these are made from the mango seed waste, and reduce our independence on the oil based plastics, and reduce the carbon footprints. Now second, which is the um, biocomposites. Biocomposites are also made from the food waste material, and also the eco-friendly material. And third, which is the bioplastics are also made from the plants such as corn or sugarcane. They are becoming popular for things like trays, bottles, and bags, especially for fresh food and drinks. And the fourth, which is the edible films and coatings. So edible films and coatings are thin layers that can be eaten, made from things like proteins and lipids, and they are applied to the food to extend its shelf life and keep it fresh and safe. The biopolymers called as renewable polymers obtained from biomass based polymer, microbial conversion, and chemical synthesis from fossil resources. The biopolymers are increasingly used in the food packaging due to their environmental benefit and the functionality. The use of fruits and vegetable byproduct, including the starches, cellulose derivatives, and the pectin. So, in the starch-based films, which are made from the agricultural products like potatoes or corn, making them a sustainable alternative to petroleum-based packaging. And the second, which is the cellulose-based films, this offers the good oxygen and moisture barrier properties, helping the food to keep fresh for a longer time. And the chitosan and the pectin derivatives or the protein based films um, are have been anti have can have antimicrobial properties and and extend the shelf life of the packaged food products. So the biopolymers are compostable. They can break down into natural elements in composting condition, leaving no toxic residues. In this diagram we can see that the natural materials from which we have been get the renewable sources like potatoes and the corn, and then which we have extract the materials like starch, cellulose, and the proteins from these materials, and then which is incorporated into the packaging material, or we have make the coating material for the coating or the packaging of the food product, as we are seeing in the image. So this is all about the biopolymer. The biocomposites are materials made from a combination of natural fibers or fillers, that is cellulose, and the biopolymers, which is the PLA and the PHA. The biocomposites combine the natural fibers with the biodegradable polymers to create the eco-friendly packaging solutions. The various biocomposites were produced by using an extrusion injection processing techniques. Example, PLA combined with mango seed waste has been developed for rigid packaging. The which is the sustainable material made from the renewable resources. Biocomposite reduce the dependence on the petroleum-based plastics. For example, the wood fibers mixed with the PLA to create a strong, sustainable packaging material. And also the biocomposites helps in reducing the carbon footprints of packaging by using renewable resources and reducing dependency on the fossil fuel plastics. So biocomposites offers a versatile eco-friendly alternative to traditional packaging materials, combining sustainability with functionality to meet the modern packaging needs. The bioplastics are the plastics derived from renewable biomass sources such as cornstarch, sugarcane, or cellulose. So in this diagram, we have been seeing that the sugarcane, corn, in from these materials, the plant-based materials is extracted, which is the cellulose, collagen, polyesters, and the starch, and which are dissolute in a beaker, dissoluted into the lactic acid and the ethanol. And in the third beaker we have been seeing that the chemical compounds have been extracted from this, and the resin and the polyethylenes are mixed into it, and with the help of these, the fourth process, which is the forming process, in which the plastic injection molding is used to make a to give the shape of a bottle. So and these bottles, which is decomposable and naturally eco-friendly, so with the help of sunlight, heat, or the UV light, this can be easily biodegradable. So this is the bioplastic, which is used in various food packaging forms, including trays, bottles, bags, and particularly for the fresh produce, dairy products, and the beverages have been successfully used. So the next slide, which is the edible coating and edible films, we will see the differences in between them. So in the edible coating, the thin edible layers applied to the food surfaces for the protection and extended the shelf life. In the edible films, the thin flexible sheets made from edible materials used to protect and preserve the food. So in the edible coating, the thin layers are applied directly onto the surface of the food products to enhance the freshness and the shelf life.
And in the edible films, the thin flexible layers that can be used as a wrapper or a packaging for a food item, which often gives the protection and the preservations. So in the edible coating, which are applied on the liquid or semi-liquid food as a protective layer. And in the edible films, the preformed sheets or films that can be wrapped around a food item. And in the edible coating, the materials such as polysaccharides, proteins, lipids, or the composites have been used. In the edible films, the bioactive films use of nanotechnology for enhanced performance is used. So the edible coating is primarily used to reduce the moisture loss, protect against environment factor, and sometimes add the flavor or the nutrients. And the edible films, which serve as a packaging material, providing a barrier to moisture, oxygen, and the light while being a part of the food items.
The next slide, which is the emerging trends in packaging regulations and certifications. So the first, which is the plastic waste and single-use plastics has been banned. Second, the digital watermarks for recycling. So what are the digital watermarks? So digital watermarks are the invisible codes or the QR codes, which provides the information on the material composition, origin, and the disposal, and also it tracks and manages the materials for efficient recycling. The benefit of using these digital watermarks is enhance the sorting accuracy and recycling efficiency. And the third, which is the sustainable packaging certification. And the fourth, which is the EPR, the extended producers responsibility scheme expansion. In this scheme, the producers responsibilities is to handle the life cycle of the packaging waste, and also the financial contribution, that is the fund recycling and waste management of the system, and also the collection target, that the consumer can set the goals for the amount of packaging waste to be recycled. And also the reporting and the compliance, the producers must report and comply with the regulations. And the fourth, which is the food safety certifications, is necessary for each and every industry of which is the food industry. The market size for the food packaging is the global demand for packaging was approximately USD 974 billion in 2018. So according to the FAO, that is Food and Agriculture Organization, the food packaging market has enormous economic value in the packaging industry with the USD 15.4 billions. It is expected that the value of smart packaging will reach USD 26.7 billion by 2024, followed by intelligent and active packaging system. The food packaging market worldwide is growing and is expected to reach a value of 512 billion US dollars by 2028. So these are the references for the PPT. Thank you. Now this brings us to the end of our presentation. Thank you for your attention. I hope this provided valuable insights into the advancement and innovations shaping the future of food packaging. Thank you so much.